Hello, welcome to this new video. In this video, we'll discuss about your method of integration, and especially in this particular video, we'll cover up method integration by substitution. So, what is integration by substitution? Let us first discuss that. Then, at least one or two examples or problems I'm going to solve. So what we'll discuss in this class is that there and widely or mostly used method of integrations are there. These are methods of integration. Very important in projects also. We use them in many cases to find out the integral value of a particular function. So basically three methods we'll be discussing in three of my videos. So in the first video, we'll discuss integration by substitution method. Integration by substitution. Then in my upcoming video, we'll discuss the rest of the two important methods, that is integration using partial fractions. Integration using partial fraction and integration by parts. So today in this video, we'll discuss about integration by substitution. So as the title suggests, it's an integration by substitute. That means we have to substitute something and we have to change it to a new variable. Then we can find out the integrals. Because in some of my last videos, I have discussed about inspection, method of inspection. So that is a general method, but some functions which you will not able to find the integration easily by method of inspection only. So we have to use certain new methods. So first one we'll discuss integration by substitution. So integration by substitution, suppose you want to find the integration of a function f of x dx. So here the function is a variable of x. The function is a variable of x, and you are supposed to find out the integration of this one. Now, if you are not able to find this function integration directly, okay, then what you can do, we can change this variable to a new set of variables so that will be easier for us to calculate the integration. Now let us do that. How we can change? So we'll choose in certain this variable x in certain way that the derivative of that your variable will be huge, and so that it can be transformed to a new set of variables and so that you can find the integration easily. For example, suppose in this function, if this is a function of x, we want to substitute this x. So let's say we will change this function x in another function, let's say g of t. This function x I will convert or I will transfer to a function of t. A suitable function I'll choose, and that is by experience, or when you will solve more and more problems, this skill will be developed in you to calculate or to choose a particular function so that you can easily find out the integrations. So this will come gradually when you solve the problems repeatedly, or more and more you will solve, the more capability will be developed within you to and choose a particular function which will be better for you. Now, then you can write that dx upon dt, we can find out the derivative. Both sides, if we'll find the derivative, so dx upon dt will be right side, it's a function of t, so we can find out its derivative. So we can write this is g dash t. This is derivative of this function. So we can write this derivative function. But left side, it's a variable x is there, so we cannot find. So dx upon dt term will come, or we can convert it to dx is equal to g dash t dt. Now this your variables x and dx all are converted to a new set of, or transformed to a new set of variables, that is t and dt. So if we want to write this again here, then you can do f, and x is now a function of g, so you can write g of t, and dx is converted to g dash t dt. G dash t dt. Now you see your fx dx is completely converted to a new set of variables, transformed to a new set of variables, that is in t. Now, why we are doing so? We are doing to simplify the problem, to simplify and to find out the integration. So this is our interest. So now when we solve one or two examples, the things will be more clear, but because this type of function of g and t might confuse you, so let us take one example so that things will be more clearer to you. Now let's go to the example. So two examples I will solve here. Let's say question one, first one question let's solve. Suppose 2x sine x square plus 1, and you want to find its integration with respect to the variable x, right? So how will you do that? Now here, this type of function, it is difficult to find out by method of inspection, or you can do, but still it will be, means we should learn how to do this method of substitution. All the function cannot be done easily by method of inspection. So here what we can do, we'll choose from here a function, so that easily when we find its derivative will be multiplied there. Means we can easily convert to a new set of variables. So let's think which one we will choose. So do you think that if I choose x is equal to t, will it solve my problem? So again, inside sine it will be t square plus 1, so it can create a problem for me. Means again, it is difficult to find the integration. So what shall I do so that everything can be transformed to a new set of variables? So the best thing, as it seems to me, if I choose, because this will, again I am saying this, choosing a function will come when you will practice more and more problem. By experience it will come. By looking at a function, you can at least predict, and you should be good at calculating the differentiation or derivative. So that by looking at a function, you can find out, or you can think of which one should I choose, so that it will be all the variables will be converted to the new set of, or transformed to new set of variables. So if here, if I choose x square plus 1 as my t, then I think this will solve my problem. Let's say, just look at here how we can. So let's take x square plus 1 is equal to t. Now by definition that we have taken, if x is equal to a function of g of t, then dx upon dt is g dash t. This is how we should convert a function to a new variable. So we have taken x square plus 1 is t. Okay, So this is our x function and this is your g of t. Now we'll find the derivative in both sides. D upon dt will do. So this function will be x square plus 1 and this will give you derivative of t also, the d by dt of t. You can do in this way. Now you can write that d by dt of x square plus 1, this will give you 2x, constant is 0. So you can write no issue. And a term will come dx upon dt using chain rule, because it's not a variable of t, right? T square plus 1, then we can find out the result will be only 2t. But if it is a function of x and we are differentiating with respect to another variable, then one term will come that dx upon dt term will come, and right side d upon dt of t is 1. So you can write here it is 2x dx is equal to dt. I'll write here. Now you see, in this, if I am taking x square plus 1 is equal to t, you can see when I'll substitute these things here, or everything will be converted to the new variable t. Let's see. So here we are getting 2x dx is equal to dt. So here 2x dx, this one. Okay. So 2x dx. Now I can write 2x dx dt and sine x square plus 1 I have taken t. So this is sine t and 2x dx is dt. Now you see your integration now transformed into a means easy function. That sine function is known to us. So a known function you are now converted to, you have converted this integrand to a new function which integration is known to you, and you can find its integration easily. So sine t dt, what is the integration? You know that derivative of cos t is minus sine t. Then what will be the antiderivative or integral of sine t? It should be minus cos t. Minus cos t is antiderivative or integral of sine t dt, right? So sine t dt, I can write this is minus cos t, and this is an indefinite integral. You know, definite integral, indefinite integrals are there, and in the indefinite integral, the boundary is not there. Means lower limit and upper limits are not there. In definite integral, lower limit and upper limits are there. So here the boundary will not be there. So we have to add one constant that you know. Now, if the question is given, our initial function is given in x, so the result we have to convert to in terms of x. We should write in terms of x, not in terms of t. So again, we'll go back, we'll replace, substitute, because we have taken t is equal to x square plus 1, so no harm in substituting it. So we'll write cos x square plus 1 plus c. This is the answer. So when you are finding the integration and we have substituted t, then we are finding out in this type of means a simple function we got, that is a known function to us. Then this converted equation finally you can means the final result you can put the value that you have taken, and you can convert to your original variables at the final equation. Final result. So now let us go for another example, then we'll stop this video. And in the next video, I will discuss about integration by parts and integration by partial fractions. So let us go for one more example with a trigonometric one. So here we will do 2 times substitution, like the function is little bit big space is required. So the question is integration 10 to the power 4 root x sec square root x by root x dx. Okay. So what you will do here, by looking at the function, you can start with two ways. Means if you are good enough in calculating the differentiation, or you are already well acquainted with your differentiation and integration, then what you can do, you can take 10 root x directly, and you can substitute. But instead of doing that, I'll do in two steps for the beginners. Then I can also show you, if you take directly 10 root x also, you can do it. So let me take first root x. Okay. So let root x is equal to t. Let root x is equal to t. So I'm doing it directly now. So what is the derivative of root x? Or if you write d by dt of root x is equal to d upon dt of t. Or you can write derivative of root x is what? X to the power half, that means half minus 1. So it will be x to the power minus half, that means by 2. Okay. So this will give you 1 by 2 root x if you know the derivative of root x. So 1 upon 2 root x, then the term will come, dx upon dt term will come, and right side is 1. So you can write 1 upon root 2x dx is equal to dt. Okay. So here I'll substitute this one. 1 upon root x is there, right? So I'll convert to dx dt in t variable first. Then also I have to do something. Okay. So let's first convert to t, because it will become 10 root x is t 4 sec square t. Okay. This root x converted to t, 1 upon root x dx. 1 upon root x dx will 2 will be multiplied here, or you can write 1 upon root x dx is 2 dt. Okay, you can write this. So 1 upon root x dx, now I'll convert to, this will become your dt, 2 dt, of course. So 2 will come here. Okay, 2 is a constant, I can write it outside. Now this x function converted to, the function in x is converted to function in t. Now still I have, means I'm not getting a simple function, so non-function, so that I can easily find out its integration. So what shall I do? I have to again substitute something. Okay, so let's again substitute. Okay, so again I'm saying, those who are already acquainted with these substitutions, they can directly 10 root x. Take 10 root x is equal to t, and you can do the algebra. But those who are doing beginning the integration chapters, you can do one thing. So what you will do, again we'll take something. What will take? Shall we take 6 or shall we take 10, which will be easier? So accordingly, you can, means you have to choose certain functions so that you can do it easily. So let me take, I think if I take 10t, let 10t is equal to z. Okay, so if I take 10t, then I think it will be easier, because derivative of d upon dz of 10t is equal to your d upon dz of z. Or you can write 10t. What is the derivative of 10t? Sec square t. So I can, this sec square t will be converted to new variable. My target is to convert all the t in terms of a new variable, transform. Okay, so that not means there will be not means there will be uh, not any single term which is available here, so that it will be in t. Everything will be transformed to z, new variable. So that's what I have to do. Now 10t is converted. I have to convert sec t, sec square t. So we know that 10t derivative is sec square t, which is 1. Now I can write, so sec square t, this is dt by dz is 1, or you can write sec square t dt is equal to dz. Now you see, I am interested to transform this equation in terms of z. Now let's see if it is converted or not. Integration 10 to the power 4 means I have taken 10t as z, so this will be my z4, and sec square t dt I got it, it's dz, so dz. Now you see, your t function now transformed to z function in z. Now this is easy. Any variable x to the power n formula you can use easily. Integration of x to the power n dx is x to the power n plus 1 by n plus 1. So this is the formula for x to the power n dx integration. Now you can easily write down that is 2. So this will be z to the power 4 plus 1 by 4 plus 1 plus c. Okay, it's the indefinite integral again. So this will be 2 upon 5 z to the power 5. Now what is your z? So I have to go back and I have to write in terms, the final result I have to write in terms of x only. I'll not write in z because my question is given in terms of x. So I need to find some integration of that function in terms of x only. So in the final result, what I'll do, I'll convert or substitute all these things, whatever I have taken. So z to the power 5 plus c. Now z is what? I have taken z as 10t. So I'll write 2 by 5. This is 10 to the power 5 t plus c. Now again I have to replace t because I have to go back to x. So t is equal to root x I have taken. So I'll again go back. So I'll write this is equal to 2 upon 5, 10, 5, t is your root x, 5 plus c. So this is your answer. So in this way, just by experience, you will gradually know which function you should take so that all the variables in this integrand will be converted to a new set of or transformed to a new set of variables so that you can use your method of integration by substitution easily, and you can find out, means the final value you can find out easily. Okay, so in the next video I'll discuss about integration by parts and integration by partial fractions. Okay, so you practice some more problems based on this concept. So as you practice, as I told, more and more you will practice, you will be able to choose the function easily and perfectly. So thank you all for watching this video. See you in the next video.